Alright, so let's do some things with these integral defined functions. And in number 23 on notes 9.3, it says a is defined as the function of the integral of 2t minus 4 dt from negative 3 to x. And of course we're going to start it off with a simple one. I'm going from a constant to a variable. So right away you should be thinking, if they ask me for a prime, then I'm going to have to just say that's 2x minus 4. Well, look what they're asking now. It's when is a increasing? Well, isn't that in essence asking me to find a prime, because a is increasing when a prime is greater than or equal to 0. So I'm just going to state a prime is equal to 2x minus 4, and a prime equals 0 at x equals 2. So I either think graphically or tabularly. I'm going to say I have a 0 value at 2, and if I substitute in a 0, I'll get a negative value, and to the right I'll get a positive value. So I'm just going to say a is increasing on the interval from 2 to infinity because it is not closed. So, okay? And if I had to justify, it's because a prime is greater than 0. B, if I want to find the maximum value of a, now 2 would be a minimum value, wouldn't it? Because my first derivative is changing from a negative to a positive. So if I start thinking about a max value, I'm pretty sure I don't have one. I wish this question asked for a minimum value. So we're going to change it because there is no max value. Think about that for a minute. My derivative is positive from 2 over, which means my original function is increasing for that entire value from 2 to infinity, so I'm not going to have a max because I'm not on a closed interval. So let's change this problem to ask for the minimum value. So if I wanted to find the minimum value, I know that it occurs at 2, but then I just have to figure out what it is. So a at 2 would be equal to the integral from negative 3 to 2 of 2t minus 4 dt. And if I want to figure out that value, then I'm going to use my first fundamental theorem of calculus, find the antiderivative. I guess you could find the area underneath the curve if you'd like, but I think it's just as easy to say I need 2t minus 4t from negative 3 to 2. And if I substitute in a 2, I get 4 minus 8. Then I'm going to subtract when I substitute in a negative 3. So that's a 9 plus 12. And I get negative 4 minus 21, which is negative 25. So if the question asks for the minimum value, which I know it doesn't, but I think this makes more sense, we're going to say the minimum value of a is negative 25. And then C wants the point of inflection. Well, quick review. We find points of inflection where the second derivative equals 0, does not exist, and changes signs. So I need the second derivative. Well, a prime is 2x minus 4. So a double prime is just equal to 2, which is always positive. Therefore, my function is always concave up, so there are no inflection points. All right, let's look at 24. How about finding the equation of a tangent line to a function defined through an integral? Okay, so let's examine how g is defined first of all. I'm going from a constant to a function 2x of 1 divided by t squared plus 1. I need the equation of a tangent line. Therefore, I need a point and a slope. So to find the point, I need g at 1. Well, g at 1 will be the integral from 2 to 2 times 1, which is 2, of 1 divided by t squared plus 1 dt. Remember, my input goes in for x. Well, the integral from 2 to 2 is just equal to 0. So I have my point 1, 0. Now I'm going to find my slope. So I need g prime. Well, the way g prime is described or defined, g prime will be 1 divided by x squared plus 1. Whoops, excuse me. Not x squared because it's defined to a function. So I'm going to substitute in 2x wherever I see a t. So it's 2x squared plus 1 times the derivative of 2x, which is 2. So if I want to find g prime at 1, I will have 1 divided by 2 squared plus 1. So this is 5 times 2. And again, I'm just substituting 1 in here. So 2 times 1 would have given me 2. 2 squared is 4. 4 plus 1 is 5. So g prime at 1 is equal to 2/5. And therefore my tangent line equation will be y equals, and I don't care what form of point slope you want to use, I'll say y equals 2/5 times the quantity x minus 1 plus 0. So get rid of that. That's just ugly. Okay, in our last application in 25, a is defined as the integral from a function to another function of 2t minus 2 dt. Find a at 1. A at 1 means I'm just going to substitute in a 1 wherever I see an x. So that will be the integral from negative 2 to 6 of 2t minus 2 dt. To find a at 1, I need to evaluate this integral. So I'm going to use my first fundamental theorem of calculus and find the antiderivative, which will be t squared minus 2t. We're going to run that from negative 2 to 6. So we'll have 36 minus 12 minus 4 plus 4. So I'm substituting in a 6, 36 minus 12. And then I'm going to subtract out, substituting in a negative 2, which will give me 4 plus 4. So that's 24 minus 8, or 16. So a at 1 is equal to 16. On what intervals is a decreasing? Well, that means I'm going to have to find where a prime is less than or equal to 0, which means I got to find a prime. So, joy, here we go. A prime will be equal to 2 times t, but in t we're going to substitute in 4x plus 2 minus 2, so that function, times the derivative of 4x plus 2, which is just equal to 4, minus, substituting in a negative 2x, I'll have 2 times negative 2x minus 2 times the derivative of negative 2x, which is times a negative 2. So we're definitely going to have to clean this up because I got to find the zeros. So this is going to be 8x plus 4 minus 2 all times my 4. And then I'm going to pull this negative 2 out front here and say plus 2 times negative 4x minus 2. Keep going, I get 32x plus 8 minus 8x minus 4, which is 24x plus 4. So if I set a prime equal to 0, I will get x equals negative 1/6. I quickly decide where my values of my derivative are positive and negative. So if I substitute in a 0, I get a positive value. Here I get a negative 1, or just think graphically. Okay? And so therefore I'm going to answer A is decreasing on my interval from negative infinity to negative 1/6. Okay? And that concludes 9-3.